Look at this gym selfie. The person in the frame is sitting on a machine, raising their right hand to hold the phone, but the reflection in the mirror appears to be raising its left hand. If the mirror is responsible for flipping horizontal space from left to right, why does the floor stay at the bottom and the ceiling stay at the top? Human intuition often fails when analyzing how light actually interacts with a reflective surface. Common sense suggests the glass performs a lateral inversion, a physical swap of the room's sides. However, subjective terms like left and right are relative to the viewer, which makes them unreliable for spatial reasoning. A mirror simply reflects spatial data across a flat plane. To understand the image, we have to track the path of individual photons. The mirror functions as a rigid geometric machine, mapping points according to the laws of physics, rather than our perspective. Light scatters off the physical raised hand and travels towards the mirror's surface. Under the law of reflection, incoming light strikes the mirror and bounces off at an angle equal to its approach. These reflected rays travel back through the room and enter the eye. The brain assumes that light entering the eye has traveled in a straight line. Since it doesn't account for the glass, it mentally extends those reflected rays backward through the mirror to a point where they appear to meet. This creates a virtual image, a projection manufactured by converging light that exists only in the mind of the viewer. If we map the vertical and horizontal axes, we see that the physical right hand and the virtual right hand align on the same side of the room. The mirror only changes one thing. It reverses the perpendicular front-to-back axis, pulling the 3D geometry inside out. Because every point is mapped directly across the mirror plane, no lateral left-right swap occurs. This leaves us with a question. If the math proves there is no lateral flip, why does the brain see one? The confusion arises because we don't process the reflection as a geometric map. We process it as a person. To make sense of the virtual image, the brain instinctively treats it as a human being standing in front of us. We then try to assign left and right to that image by comparing it to our own body. To occupy the image's position, we actually imagine performing a full 180-degree turn to face back toward ourselves. That imagined rotation, not the mirror, is what exchanges left and right in our mind. The illusion comes from imagining that the image has turned around to face us.